find limits is by looking at the graph. This is probably the easiest way to find the limits because it's very visual. Okay? So I'm going to give you three different graphs with three different approaches. So the first one is for h of x. Okay, h of x here is this little graph right here. Okay, so all we need to do is to find the values of these limits given that graph. So it says when x approaches -4 from the right of h of x. So this is -4. Notice that when it's approaching -4 from the right, it's slowly but surely heading to what? To negative infinity. Okay? Because there was a vertical asymptote at -4 and the graph is moving towards negative infinity. When x approaches -4 from the left, notice how the graph is slowly but surely approaching positive infinity. Okay? When x approaches infinity, positive infinity, notice that it's also approaching a value, in this case is 5. And when x approaches negative infinity, you're looking at this graph right here, this part of the graph, is also approaching 5. Okay? Now a little bit more challenging will be this one. So it says when x approaches a from the right. Notice that we don't need actual values, okay? Having letters like these are perfectly fine. So this is g. When a is approaching from the right, my function, my graph, is going up to positive infinity. When x approaches a from the left, my function is going to negative infinity. When x approaches 0, 0 here, it's equal to d. It's actually continuous at d. When x approaches infinity, notice here, positive infinity approaches c. When x approaches b from the right, it's approaching positive infinity. When x approaches b from the left, it also approaches positive infinity. Okay? Now a little bit more challenging will be a graph like this. When x approaches positive infinity, notice that this here is the part that approaches positive infinity for x, and it is approaching f. When x approaches negative infinity, notice this is the part that approaches negative infinity in x, so it's also approaching f. When x approaches from the right of a, this is approaching negative infinity. Okay? When x approaches from the left of a, notice here, it's approaching positive infinity. Now, since these two are not equal, it does not exist. Okay, and I wanted to add that here we have infinite essential discontinuities, in other words, infinite discontinuities. When x approaches 0, when x approaches 0, it's just 0. When x approaches b from the right, notice that my graph is approaching negative infinity, and from the left is approaching positive infinity. Okay, let's see, do we have more? Yes, we do. Okay, so here, when x approaches b, notice that again these two are not equal, so it does not exist. Now let's look at c. From the right of c, it approaches negative infinity. Oops, that's not the one. I'm going to do it in this side so we can stay with it. So when x approaches c from the left of our x, from the left of c, it approaches positive infinity. from the right of C, it approaches negative infinity. Actually, it approaches J, okay? Even though there's an asymptote there, it actually approaches J. But since these two are not equal, again, does not exist. From D, again, here, if you search it from the left and from the right, is approaching K. At E, from the left of E is approaching positive infinity. Well, let's see. Actually, from E, it approaches F as well. From the left and from the right is negative infinity. So let me change colors because we've been using blue too much. So here, when X approaches E from the left, it approaches F. But when X approaches E from the right, it approaches negative infinity, therefore does not exist. R of E, notice that is defined here at I. R of 0 is 0. R of B is not defined, so undefined. And R of D is also defined at K. Okay? And that will be all for this video. If you like the video, please subscribe to Motivo. Share with your friends, share with people who are taking the AP Calculus, and let me know what you think about it. Thank you.